Okay, so what we're going to be working on today is solving systems of equations using substitution. First of all, it's important to remember that a system of equations is two or more equations. Now, equation, of course, means it has an equal sign. So we're looking for two expressions that also have equal signs in them. So they could be y equals, which is slope-intercept form, or they could also be in standard form with x and y on the same side. But the idea is, how do we solve when we have two of them? Okay, you can solve them three different ways. First of all, we can solve them by graphing. Okay, we're going to look at an example of that, but that's not the most algebraic way of solving them because it relies on us drawing lines, and there's some issues that can come up with that. Second is a way called substitution. You probably heard the word substitute before. We've used substitution in a different way earlier this year, so we'll go back and look at that and make sure we understand how to apply it to what we're doing now. And elimination, which, if you've heard the word eliminate before, means to get rid of. So in elimination, we're going to be looking to get rid of something. Okay, so to start off, we're going to look at an example of solving by graphing. Okay, now anytime we solve a system of equations, they are two lines. If you remember from the graphing unit, they're two lines, and any two lines will cross each other either one time, no times, or they'll always cross each other. And we'll look later at why that has to be true. But for now, anytime we're asked to solve a system of equations and there is an answer, it's going to be a point, an x and a y, where those two lines cross each other. It's very important to remember that you're always solving a system for a point, not just an x, not just a y, but both an x and a y. So the way we mark that is we go ahead and put the parentheses, the empty parentheses where we're going to go ahead and put our point in our ordered pair. I like to encourage my students to do that right away. As soon as you see you're doing a problem like this, write the point. Why? Well, you can't only answer half of it. You have to answer both halves, or you're left with a half empty answer. So we're going to go ahead and start by solving this by graphing. So as you can see, I've got a nice graph here, and I'm going to just basically graph each of those points. The top one has a y-intercept of -7 and a slope of 2 over 1. So up 2 over 1. Go ahead and draw my line. Now I'm going to go ahead and graph the bottom one. I decided to graph it by intercepts because 10 is easy to divide by 2 and divide by 2 on the other one. Sometimes it's not necessary or not easy, so we want to use our slope. We could do either way here. So I go ahead and I figure out, all right, my x-intercept is 5 because 10 divided by 2 is 5, and my y-intercept is 5 because 10 divided by 2. And if you don't remember that, basically what we do is we take a turn here, and first we cover up this one. We say, all right, so then 10 divided by 2, y equals 5. Then following that, I go ahead and I then cross off my y, and that gets me my x-intercept. And you can always do that, as well as, if you remember, we used to do the opposite a over b thing. So if we'd have done that, we would have ended up with a y-intercept of 5. But we could have done opposite of a, which is 2, over 2, which would have given me a slope of -1. If you graph this, you'll see, oh, okay, that actually does give me a graph of -1 that crosses at 5. Okay, what we can do then is we can identify where is the point where they cross. Well, if you look at my graph, that point is located right where the two cross each other, which is right there. Okay, that point is at 4, 1. Okay, this method is useful. We can do it if we have a graph and we're very, very careful. We can get the answer this way. However, we're going to kind of think about why that's not the best way to do it. Okay, so before we get into actually solving it using elimination, I want you to kind of think for a second. What are some of the drawbacks to doing that? You know, what are some of the drawbacks to graphing a line and trying to solve that way? So think about that for a second. You can pause it if you'd like. But I just want you to think, what are some of the reasons why we would not want to use graphing as a means to solve this problem in general? Okay, well, here's a couple that I came up with. You might have thought of some others. Your graph has to be perfect to get the right answer, even to get an answer. If my line was a tiny bit off on my graph paper, it wouldn't have crossed at exactly 4, 1. The answer would still be 4, 1, but my graph would have led me to a wrong answer. In addition, any mistake, even the slightest one, and not only will you not get an answer, not only will you get a wrong answer, but It may even look like a right answer. And it takes a long time. I mean, you need to have a grid, you need to have the setup, and it's going to have to take time to plot the points, figure out the slope and y-intercept. And like I said before, you need an actual grid to be able to do this. Any mistake on your slope, any mistake on your y-intercept, forget it. Everything's going to be wrong. So there are a lot of areas that you can make a mistake. And some people just don't like graphing, so it's nice to have an algebra method to do it too. As we always talk about, we want you to have multiple ways. So if you go ahead and graph it, that's fine. Maybe use the algebra to double check your math. Okay, so what we're going to do is we're going to take the same problem. We already know the answer to this problem. It's 4, 1. But we're going to use a method called substitution. Okay, right off the bat, you need to know why I'm going to use substitution. That's something that is confusing for some people. Well, one of the things about substitution is we're looking for a problem that has a y equals or an x equals. So when we look at our two equations up there, and again, my two equations are the top one here and the second one here. Those are my system of equations are those two. When I look at those two, I'm looking at, is one of them a y equals or an x equals? In this case, as you can see, that one right there is y equals. That's a big clue. When that happens, it has to be a substitution problem every single time. So what we want to do when we do that is use substitution. Well, let's look at what substitution is. We've used it in the past. Here's an example. Simplify 3y equals 9 if y equals 5. You didn't know this was substitution, but this process is really substitution because what we're doing is we're taking that letter, that y right here, and we're saying, you know what? That right there is supposed to be the same. So instead of a y, I want to use a 5 in there. I want to know what 3 times 5 minus 9 is. You probably would do this problem in your head. 3 times 5 is 15. 15 minus 9 is 6. We're going to mimic the way we would do it in a system of equations, an algebra problem. What we would do is we would rewrite the original equation, but instead of that y, we're going to substitute it out for parentheses. And earlier in the year, we did this, and this is why we're building up for this. It was easy back then. You didn't need to do it. You could do it in your head. Now, you won't be able to do these problems in your head. You need to have a very steady, very repeatable process you can do every time. So what we're going to do is we're going to follow these steps. Take the equation. Okay, take the one that's not y equals. Take the other thing, 3y minus 9. Substitute in for parentheses. Inside those parentheses, we're going to put the thing that we know. In this case, we know y equals 5, so we're going to place that 5 inside the parentheses. Then, after you do that, all that's left to do is simplify. 15 minus 9 is 6. This is a problem we can do in our head, but the process is substitution. And it comes from this step right here, the word substitute. When we plug it in there, it's like a substitute teacher. It's stepping in. It's replacing the letter y with the number 5. That could be for an x, it could be a y, it could be a z. For here, we're going to substitute either y or x. And the problem will tell us. We're not picking at random. We're always substituting in the one that is by itself, the letter by itself. Okay, so again, we're going to go ahead and apply it to this problem right here. Well, we're going to look and say, okay, here's what I have. Instead of y equals 5, this time I have y equals 2x minus 7. The clue again is that y by itself. I went ahead and I used colors here to help you kind of visualize it, but you're going to locate that y. The known thing is that other side of the symbol, 2x minus 7. In the bottom equation, what I'm going to do is the same thing I did on the last one. I'm going to start with the other one. Okay? I'm going to start with 2x plus 2y equals 10. Always do that. You always start with the other equation. Okay, whichever one's not y equals or x equals. Then I'm going to replace that letter, the y letter. Okay, in this case it's y because of the y equals. I'm going to replace that with an empty parentheses. I'm going to rewrite everything the same except I'm going to leave an empty parentheses. In that parentheses, I'm going to substitute in that 2x minus 7. Every single time this problem is done the same. So make sure you're following the same process every time. Figure out which equation is going to be substituted. Take the other one and replace the letter with empty parentheses. At that point, just like last time, all we do now is we simplify. So I distribute the 2. Okay, take that 2 on the outside. 2 times 2 is 4. 2 times negative 7 gives me my negative 14. Okay, at that point I can now solve. Combining like terms gives me 6x minus 14. Adding 14 to both sides, 6x equals 24, which gives me x equals 4. This is where everybody stops. I got my answer. Man, that was a lot of work. Okay, x equals 4. Done. Not right. Here's why. If you remember way back at the beginning, what I said is every single time we start with an empty point. The reason is it gives me two places to fill in. This is my x. This is my y. All I've done at this point is I've figured out the left side of the equation. Still valuable, but if you leave it like that, your answer is wrong. You just told me somewhere near where the point is. But there are an infinite amount of y answers that can go in there, so it's not correct unless you give me an x and a y. Okay, so how do I figure out the y? Well, here's what I do. All I'm going to do is I'm going to do a second substitution. Don't worry, it's not going to be nearly as hard as the first one. I already know half my answer now. So all I'm going to do is I'm going to go ahead and I'm going to plug in that 4 into one of the two equations. Okay, the answer is which one, right? You're going to ask me, which one do I have to plug into? It doesn't matter which one you plug into. You should plug into whichever one will be easier to solve. So go ahead and take a look at those two. What do you think? In fact, it doesn't matter which one you pick. Some people will pick totally different ones than me on this, and I'm kind of surprised. I'm like, man, it's obviously the top one to me, but they picked the bottom one. It doesn't matter as long as you are able to solve the problem. Some people don't like to deal with negatives. Some people like to solve two-step equations. You can do it however you want. I prefer to plug into the top one in this case because it's y equals by itself. In general, I'll tell you, substitution problems, it's always easier to plug into that one, the x equals or the y equals. But you can plug in whichever one you want, it'll be fine. In fact, it's a good idea to plug it into both just to check and make sure your answer is correct. So what I'm going to do now is go back to our original thing. We're going to take that letter we know, okay, and remember, this is our x up here. Okay, so we locate our x down here, and I'm going to go ahead and I'm going to follow that. I'm going to substitute that 4 into there. Simplify the problem. 2 times 4 is 8. 8 minus 7 is 1. Now I have the second half of my answer. Now I can plug that up here, and I'm good to go. At this point, I finally have my completed answer. If you put that point there as the very first step, you'll make sure that you don't forget both parts of it. Many of my students will get the x and leave it like that. And it's not your fault. You're used to solving two-step equations with only one variable. You've never solved for an x and a y before. So this is a big deal. It's a new thing. Up until now in algebra, most of the stuff's pretty much review. Maybe a little twists on what you've done before, but nothing big. This is the first thing that's really kind of shockingly different. You want to make sure that you really follow this process of putting that empty point up there, the empty ordered pair, so you remember to give yourself two answers. We're going to take a look at one more before I have you try some on your own. So go ahead and take a look at this equation right off the bat. What we're going to try to do is we're going to try to follow that same set of steps. First thing, identify the letter that's by itself. Hopefully you notice it's the x. Okay, again, here we go. I got my x by itself. As soon as I notice that, what I want to do is I want to say, okay, I'm going to take that y minus 4 and I need to substitute it into the other equation. You're always plugging into the other equation. So step 1 is take that other equation, that 3x plus 2y equals 33, and write it with empty parentheses where the letter x is. A very common mistake here. Okay, so again, I like to underline it on there. You don't have to, but it's a good process to do that. And there's my x up there. A very common mistake here is to substitute that in to the wrong spot. Usually we plug in y, so they'll plug it in for y. And what you end up with is x's and y's in the problem still. You end up with something like this. You go, okay, I'm going to go ahead and substitute. I'm going to get 3x plus 2 y minus 4. Very common mistake, because this is a lot like what we just did a second ago. We substituted the y. Well, if you notice, we still have y's and x's. We didn't get any simpler. The part of this process, the substitution piece, is to end up with only one variable. It's very important that you do that. So obviously that's not correct. We're going to take this and we're going to rewrite it with an empty parentheses. Inside that parentheses, I'm going to put in my y minus 4. I'm then going to distribute, combine like terms, and solve my two-step equation. Okay, again, this is pretty much a review of those basic steps, but if you do have any questions on any of the steps, just bring those into class to me. But we're combining like terms, adding 12 to both sides, and dividing by 5. That has given me half of my answer. before you quickly throw it in here, make sure you put the y into the correct spot. It's on the right side. You have to be careful and pay attention to detail. Okay, now we're going to substitute back in. Remember, you can substitute that 9 back into either equation, the top one or the bottom one. In substitution, though, it's very simple to plug it into the one that's the letter by itself. So I'm going to plug into x equals y minus 4, substituting my y for 9. As you can see, I'm going to get x equals 5, and that completes my point. Okay, a lot of explanation for the first example. As you can see, it'll go quicker as you get good at it. The key here, to me, the most important part is this step right here. The step where you replace the letter and substitute it incorrectly. That's the step I see the most students having trouble getting started on, as well as making a mistake. So be very careful and pay attention that you're distributing correctly. Okay, so we're going to go ahead and try one on your own now. What I want you to do is pause the program. Okay, try this problem. Remember to do both steps. Remember to put your blank point. And after you're done, hit play and we'll check and see if your steps and answer are correct. Okay, so as we start this problem, I want to make note of one thing. You could do the problem slightly differently sometimes. In this case, I think it's going to be pretty much exactly like mine, but sometimes when we do problems, you may have slight variations, like when you plug it back in and things like that. Don't worry about that. What we want to know that's the same is we want our final result down here to be the same. If that answer is the same, it doesn't matter what method you got. That's why graphing is an acceptable method, just not a very good one, because it's hard to do, takes too much time, and it's easy to make mistakes. Okay, so the first thing I like to do is identify what's going to get substituted. I'm going to take that y and I'm going to switch it out for x plus 8. So I'm going to rewrite the bottom equation with parentheses instead of that letter y. Take a second to make sure you understand what I just did there. Okay, now I'm going to replace that with x plus 8. This is where people have to be really careful. A lot of you will probably end up with 4x minus x plus 8. You have to remember that this is sort of like an imaginary 1 out here. So when you distribute it, that negative 1 needs to get distributed to both. Okay, 4x minus x equals 3x. Adding 8 to both sides, I get 3x equals 6, so x equals 2. If you did get this part wrong because you misdistributed or something like that, why don't you just pause it, give yourself a second to fix that and kind of finish the second half of the answer so you don't have to get frustrated. It's very common to forget to distribute that negative sign. Okay, so now we're going to plug that 2 back into the top equation. I again use the top equation because it's easier. Whichever one's easier is where you want to plug it in. Okay, 2 plus 8 is 10, and that completes my answer. Again, I'm writing these step like that. You could have skipped sort of this step right here because that's basically just a step where we leave it blank. I just want to show every step of the process for those that are following along. Okay, so once I have my final answer, I can go ahead and say that's it. I like to circle my final answer just to give the person reading it an obvious place to look for the correct answer. And you will be required to do that in my class if you haven't been already. Okay, so moving along, here's another one for you to try. And notice you have the y equals on top as well as a problem on the bottom. Pause it. Be very careful to pay attention to negatives and combining like terms in correct way. So do that. Pause the problem. Make sure you write your point down at the bottom. And when you're finished, hit play and we'll check your answer. Okay, so first thing I do, identify what's going to get plugged in. It's going to be 5x plus 6. Why? Because the y is by itself. Where am I going to substitute it? It's very important. I'm substituting in for the letter y. The letter that's by itself is what gets replaced. So then I rewrite my equation. Notice I substituted that in, replaced it with empty parentheses, substituted it in, distributive property, combining like terms, 20 minus 3, subtracting 24 from both sides, and dividing by 17. Okay, that gives me my left half of my answer because that's x, and I choose to plug it back into the top one. Again, I always choose the top one. You can plug it into the bottom one, it's fine. You're going to get the same answer either way. Otherwise, you did something wrong. So I'm going to get 5 times negative 1 plus 6. That's negative 5 plus 6, which of course makes my answer positive 1. Okay, so at this point, I'm going to give you some more examples to do on that quiz. So below this video, you'll notice there is a link. Please follow that link to the quiz. Take the quiz so I can see your results for class tomorrow. And go ahead and fill out the form down below. Make sure you put your name and answer all of the questions so I can give you credit for having watched the video.